Welcome, everyone. We're just about to get started. There are probably a few of you who know me. I'm Andy Smolik. I've been at Identiverse for the last 10 years with 4 different companies, and this time around I was going to present this, and I wasn't able to, but I recruited Iain, who is fantastic, and you're going to enjoy this session. The two of us represent 2 of the 4, I don't know, founders of AppAuth, I think is fair to say. He'll talk about that a little bit, but that's towards the tail end. Iain, and especially I want to thank his employer, the We Company. Iain and I worked together at Google in the past. The We Company was kind enough on very short notice to allow Iain to come down, and you're in for a treat today. If you haven't spent very much time in mobile identity, this is where to start. Let's give everyone a warm welcome for Iain.
So good morning, everyone. As Andy says, I'm Iain McGinniss. I'm a principal software engineer based in San Francisco with the We Company, formerly WeWork. My main area of responsibility there is driving forward our permissioning model for digital and physical access. A big part of WeWork's business is, as was said in some of the earlier talks, like right people, right access, right time, sort of right constraints on those types of things, and trying to move the business from a very upfront subscription model of you pay for a WeWork membership, you get access to the space for some relatively long period of time, usually like at least a month, to much more like on-demand usage. Like I need a conference room and the WeWork that's right across the street from the conference center right now. Being able to do that within the app and get access within 10, 15 minutes max. So that requires a fairly fundamental shift in infrastructure and thinking to enable that type of thing. And that's what makes interesting to work at WeWork. So, and also, as Andy said, I formerly worked at at Google. I used to be part of Google's identity platform team, focused on, in particular, mobile authentication and APIs to support streamlined mobile authentication. So that's my background that's particularly useful to give this type of presentation. And as part of that work with Google, I worked on the AppAuth suite of libraries. I was the lead maintainer of that for a number of years. So AppAuth, again, is a library to make it much simpler for you as a developer to integrate with OAuth2 and OpenID Connect identity providers. It takes care of a bunch of the sort of tricky details across the 3 main platforms, so that being Android, iOS, and Electron-based desktop applications or Cordova-type JavaScript-based applications on mobile generally. So having said that, I'll jump into the sort of meat of the talk. So what I'm going to be talking about mostly is the ways in which the operating system helps and hinders your efforts in coming up with a mobile identity strategy. There are definitely some unique user experience and security challenges in this domain. From the user's perspective, that a lot of the time the device is sort of an extension of them. They see it as like, this is me. But the operating system and the apps don't see it that way. So it's trying to make those 2 perspectives gel in a way that makes sense to the user and minimizes friction for things like authentication and re-authentication on those devices. And where this is all heading towards is that single sign-on, in my opinion, is essential on mobile devices. There are so many frictions to things like password entry and multi-factor authentication on mobile devices that you really want to kind of nail that in one place at your IDP configuration or the kind of core application in the suite that you're building, and then leverage that across multiple applications so that the user isn't constantly having to re-authenticate. And some other aspects to that too, like how often should you re-authenticate users, that comes into mobile authentication as opposed to desktop authentication. So first, we'll start with the sort of notion of the layers of identity or identity context and isolation on mobile devices. So with most mobile platforms these days, users have to register an account or authenticate to an existing account upon purchase of that device. For enterprises, that might also mean it's been set up through a mobile device management platform up front before the device is given to the user. But at some fundamental level, that operating system, and by that I mean the core OS and the core set of applications that get shipped with that device have some notion of the user's identity. And they use that for things like updating applications, for deep integration of that identity into those core applications. So Gmail already knows who you are when you sign in with a Google account, these types of things. However, that core of identity information is not shared very readily from the operating system. And there are some significant differences here between Android and iOS as well. So we'll get into that now. So starting with iOS, it's fundamentally a black box. So they have their identity information for the Apple account, and in virtually no circumstance do they share that information to an application running on the device. This is now changing with iOS 13, which is coming at the end of this year. So now we have a sign-in with Apple API, which is broadly speaking OAuth 2 compliant. That gives you a way to quickly authenticate the user using the account that was already seeded onto the device. Utilize things like Face ID and stuff like that for authentication and re-authentication. But the identifier that sign-in with Apple gives you is an obfuscated identifier. You get these directed identifiers per app to prevent any correlation of user activity across multiple apps. And even the email address with user choice can be obfuscated. So you might get something that you don't get the real user's email address. You get something that proxies through Apple and gives them a way to shut down any communications that you send to them if you're being spammy with that email address that you provide. So this has a bunch of nice properties from the user's perspective, particularly around privacy and mitigating tracking on the web. But depending on the types of applications you're building, this may end up being just the wrong approach. So if you have know your customer type legal requirements, these obfuscated identifiers and email addresses are nowhere near sufficient to cross that bar. So you're probably not going to be able to use sign-in with Apple for those cases. But for a lot of consumer apps, this is actually totally fine. And I think as an industry, we'll need to adapt to this type of thing and get used to the idea that we don't have some direct knowledge of the customer until the point at which maybe they pay for something or some other higher touch action. Then initially, most of our users are essentially pseudonymous. So that's something that a big change that's coming, and I think it probably will come on Android at some point soon. I don't have any insider information there, but I don't expect they won't respond to this. So on Android, you can get access to the accounts that are on the device. There's a notion in Android applications of asking for permissions from the system. So the main permission that's pertinent here is the get accounts permission that gives you a way to see all of the list of all of the accounts that have been registered into the device. These accounts get registered through what are called account providers. So an application can register an account provider for a particular domain or identifier. And this is actually what the Google apps themselves do. So the very core application of a Google approved device is Google Play Services. It acts as the account provider for Google accounts. And all of the other applications across the Google network will utilize that information from Google Play Services as the bootstrapping of their account information, things like the active account, stuff like that. But you can use this too. So this is, at least in the early days, how Facebook would do this too, where they would register the Facebook account through an account provider in the main Facebook application. And then other applications like Messenger and so on would utilize that information from the main Facebook app to bootstrap themselves with the same account profile. As you can see, I just took a screenshot of my own device. So there are a bunch of things in there that don't really look like accounts in a traditional way, and that's where we get into sort of abuse of this API, the fact that the API is not particularly well documented or just very well set up for the types of single sign-on that we want to do these days. So there's some odd things in there, and you, as a user of this type of API, have to be prepared for that, filter out the things that are not relevant, focus on things like Google accounts or LinkedIn or something like that within that API. Also on mobile devices, there's the just general concept of multiple sign-ins. So it's very commonly used for bring your own device type use cases. Every employer I've worked for since I've had an Android device has utilized this, where I had my personal account and my work account on the same device inside the same context. And I can switch between those, particularly in the kind of core applications like Gmail or Calendar might show a synthesized view of both calendars in the same view. So that is more of a like application level thing. Like those multiple accounts exist through the account providers, but the applications decide whether or not to use that information and expose it and how they expose it. There are no common UX frameworks or even patterns really that you can leverage here. Is very much a decide for yourself how you want to handle multiple sign-on on iOS, on Android. On the iOS side, again, because the OS is effectively a black box, you have no access to any of that type of information, and the OS itself is fundamentally a single user. You have that sort of baked-in account from the point of device setup. So this is very much a kind of Android-skewed piece of the talk. Android also has a pretty well-hidden feature that's not used very often called Android profiles. So you can actually set up entirely separate contexts on the device where I might have one context for myself and one context for my partner on a tablet, and we can switch between those two contexts through the settings menus. We can have completely different apps installed. We can have completely different settings for things like accessibility, font sizes, stuff like that. There are some shared settings between these two profiles, but fundamentally these are completely different things. It's almost like it's two completely different devices on the same device, and you have to explicitly switch between the two. Like I said, it's not particularly well exposed or even used. It was introduced primarily for tablets and never got a lot of traction. And some manufacturers like Samsung just straight up remove this from the OS. Like you just don't, it's probably there at some level, but they don't expose any of the UI that allows you to create or switch between profiles. But this can be useful in a business context too for shared devices for field workers where you might want to use profiles as a way to switch between multiple users. Android also has some built-in enterprise features. So they had a product that was called Android for Work. I'm not sure if that's been rebranded or doesn't really have a name anymore, just fits under Android Enterprise generally. But this would allow you to have two accounts, like a personal account and a work account, within the same profile. But the view is essentially the layering of two profiles. So you would see like a personal Gmail app, and then next to it, a work Gmail app. It looks like two separate apps with different icons or an icon annotation. And what this was intended to do was to give enterprises a way to do remote wipes of just the data that pertains to business for bring your own device use cases. So you could provision a user onto this, their own device. They would have a set of work apps. It would be very clear to the user what data was personal versus work because of the app separation. But then at the end of the day, when you offboard that user from that profile, you can just remotely wipe all of this data. It's encrypted with different keys and everything on the device as well. So popping up the stack a little bit, so within web or sort of native applications on Android, a much easier way to get a handle on these kind of core accounts that we're used to for Android, Google accounts or accounts that are exposed through the Google Identity Platform, is to use the Google Sign-In native APIs. So they give you that top right diagram is what you would see through Google Sign-In on the native APIs, where it will list the Google accounts or accounts that are registered through the Google Identity Platform. And with one tap, you can pretty much get access to that account. If there are any special consent or permissions required, that would be shown serially after that inside that same dialog box. So you can very quickly get through the process of provisioning a user, particularly for consumer apps, by using this native Google Sign-In API. On the web, there's an equivalent to this, which is called the one-tap sign-in API. That was one of the last things I worked on at Google before I left. It provides a similar experience, but within the web browser. So previously with Google Sign-In on the web, it would have to open a pop-up or do a full page transition to accounts.google.com, where the user would go through a very similar flow to what you see at the top right. And then it would redirect back to your application. So that was using the sort of traditional OAuth 2 type flow for getting user account information. With one tap, it's shown as an iframe within the context of the application. Communication is done through post message between the parent page and the iframe. And that allows us to have this sort of like integrated experience where, particularly for mobile, it just looks like a standard bottom sheet type presentation. It appears within the context of the page without having to fundamentally change the structure of your application to support this. It's still in beta. There are a bunch of really tricky sort of security and privacy type concerns around this with clickjacking and stuff like that. So currently this is whitelist based. You have to have your domain registered on a whitelist to use this. We have to pre-vet some of the code to make sure that you're not misusing this API in any way to force users to sign in. But my hope is that over time, this will become a much more standard approach for integrated sign-in into web applications. So the Google Sign-In native API is one very important thing you have to be aware of there, is that they only really work on approved Android devices. Those are devices that have the core set of Google applications like Gmail and Chrome. If the device doesn't have those, which means it doesn't have Play services, then the native APIs just won't work. So there you have to fall back to using something like AppAuth or authentication in the browser, which I'll come to later on in the talk and talk about how that actually works. So one other kind of useful layer that the operating system provides for us for storing identity information is this keychain API that exists on both Android and iOS. It gives you a way to generate device-bound keys for your application. So you have this isolated keychain, and you can utilize that for doing things like signing operations or cryptographic operations, so that if you retrieve something like a refresh token as part of some OAuth 2 flow, you want to store that on the device, but you want to be extra careful that if someone is able to pull the data off that device, that's encrypted using keys that are very difficult to extract from that device, and that's what the keychain APIs generally provide. So through that, we can bind tokens to the device notionally, not concretely, the way that we're trying to do now in the OAuth 2 specs. But there are also some issues with that, particularly on Android. Older versions of Android, if you change the PIN on the device, or if an account was added to the device, it would wipe all those keys. So then if you're utilizing those keys to protect data on the device, you'll lose access to all of that data now. It's like the keys are gone. So that would mean as part of your application design, you would have to accommodate for that. So if they realize that the keys have changed, then you can't decrypt the data. It's essentially throwing the user right back to the initial state of re-authenticating, re-instantiating everything that's required for that application. With newer versions of Android, I think post Android M, this is no longer the case. You can choose the scope of these keys in a way as to whether they get wiped or not. So generally that provides a better user experience, that they're able to change the sort of fundamental lock of their device without affecting all of the applications as a consequence. One other nice feature about these keychains on both platforms is it's possible to share these keychains between certain apps. And the restriction typically on iOS is that the apps have to come from the same team ID, which means effectively the same developer. If that's the case, then they can share the contents of the keychain. They can even share data through a shared data store. And that gives you a very easy way to share account information. And this is exactly what Google apps do on iOS. So they'll do their first sort of authentication run on the web through whichever application you install first, usually like Gmail or Chrome. And then past that, if you install any other Google apps, they're able to pick up the identity context from the other Google apps on the device through the shared keychain and shared data store. Android, the restriction is slightly different, is that the apps have to be signed with the same signing key. Mostly means the same thing as the same developer, though some issues I've seen from my time in Google is that when you, say, acquire another company and that app becomes part of your portfolio, it has a different key because they were a different developer. And if you try to rotate the keys on that app, usually that means that all users have to uninstall the app and reinstall the app. They won't get any automatic updates or anything anymore, so there are some real implications to doing that you have to consider as well. And there are other ways you can share identity information on Android that don't rely on the shared keychain. They just end up being much more complicated in this approach. So this is something to consider as to whether you're confident enough that your keys will remain consistent across the suite of apps that you develop to use this technique, or whether from the start you have to invest in one of the other techniques to share account information, so that if you do acquire new apps or build new apps from developers in contexts where you don't trust them with giving them the same private key for signing, you need to use a different approach. So finally, we mostly talked about things like what the OS provides, the OS layer to the app, and now there's also the special app that's on most devices, which is the browser, which is a very powerful identity context and the one that most of the standards really expect you to be using. So OAuth 2 and OpenID Connect assume some sort of browser-based relying party for the purposes of those protocols to operate. So most browsers don't have some intrinsic notion of identity. User doesn't necessarily sign in to the browser. Firefox does have sort of Mozilla accounts you can use to sign into the browser. Chrome usually will use the identity context provided from the device if it's Android, or have the user sign in on the very first install on iOS. But an important thing to know about Chrome is that that set of accounts between Chrome and the device can get out of sync. So you can end up in strange cases where you might think that you're doing single sign-on by throwing the user out to the browser, but they actually have a different set of accounts there. And then when they try and add an account, it throws them into some Chrome-specific add account flow, and it just gets very confusing. And I've seen a bunch of developers trip up on that point, especially if Chrome has not been seeded with the right accounts in the first place. So aside from that, as like the kind of core of what the browser has, it generally won't share that. Chrome might inject some of the account state from the sign-in account for the profile into the browser to make Google sign-in easier. But that's just Chrome. That's not necessarily across all browsers that they'll do anything useful like that. So most of the identity context in the browser comes from the cookies and the browser local storage that comes from the IDPs that you interact with. So as Vittorio was talking about in the last talk, usually after a user authenticates with the IDP, whether that's Google or Okta or Auth0, a cookie, an authentication cookie, will be held on the domain of that IDP, such that any subsequent operations to sign in accounts using that IDP can reuse the existing authentication context for that. So that gives you that either just one-tap confirmation, yep, I want to sign in as Iain@wework.com, or the ability to add more accounts through that context and have that persist for future uses across other applications that are doing single sign-on. The most common method of sharing that type of information, as I mentioned, is through protocols like OAuth2 or OpenID Connect, which rely on full-page redirects that will change the context of the application in a very noticeable way that I think was originally utilized because there weren't very many other mechanisms to do this. Now there are a lot more ways you could potentially share identity information. But it also makes it clear to the user that they're potentially authenticating in a secure context. Like they can look at the address bar and they can see, right, this is definitely accounts.google.com. I see the green padlock. If I click on that, I can see more detail if I ever go that far. Most users don't. Whereas other mechanisms like crossed origin requests or iframes don't show the sort of proof that this is really the IDP that you're interacting with in those contexts. Like they happen completely in the background, unbeknownst to you. Or they happen within iframes, and then you have the real risk of clickjacking or sort of like spoofing of the UI of the IDP that you're interacting with. And unless the user's paying attention, they may not realize that they're being phished, essentially, at that point. And this is where 2FA and MFA becomes really important to help mitigate those types of attacks on the user as well. So a recent development, something that's been causing a lot of consternation in this community, is intelligent tracking prevention on Safari. So it's a feature that's designed to protect the user's privacy by blocking the use of third-party cookies. So if I make a cross-origin request from video.com to news.com or vice versa, the cookies that were on the third-party domain will not be carried because they can be used to track me. And this is exactly how ad trackers work. Unfortunately, it's also the technique that we would use for identity, because ultimately identity and tracking look very similar in terms of the techniques that we use. So this causes real problems for some of those more transparent authentication techniques. If you do full page switches, the way that OAuth2 or OpenID Connect do, things will generally work better because it's very much in the front context of that browser versus something in an iframe or something where the user doesn't know for sure it's the real IDP or that they're being tracked through this iframe. And the one sort of escape hatch that Apple gave us here was a storage access API, which I believe is now also available in Mozilla. So it gives you a way to specifically say, I really need to be able to use these cookies in this third-party context, but it's on a point-to-point basis. So in the example here, it's like embedding a video in a news site. So really what that means is embedding YouTube in some sort of New York Times type context. You want the user to be authenticated on YouTube so they don't see ads if they're paying for like YouTube Red or something like that. So in order to do that, the embedded context has to say, I need to be able to use these cookies, and it will pop this dialog to the user saying, are you sure you want to allow use of these third-party cookies? With the warning that that means they can track your activity, because that's very much what they're trying to make sure the user's aware of. But for us in the identity world, This means we have to kind of wrap this dialog if we want to use this technique to say, we're not using this for tracking, we're just using this so we know who you are, and we can provide a secure, authenticated, authorized context for the types of operations that you're trying to do. The one kind of last niche, though, pretty commonly used on Android in particular, is embedded web content within applications. So their entire applications where actually all of the implementation of the app is done in a web view. So you're really just presenting what would have normally been in a browser through some installed application. People used to do that in particular so that they would be discoverable through app stores, even though the app would work perfectly fine on the web. They just wanted that discoverability. But it also has some other advantages. So especially if you're in a sort of transitionary period between what was like a traditional page turn type web application and a native application, this gives you a way to bridge these two worlds. So for some of the content of the app, you can do it as a like web view embedded web content. Other things you can do native. And the APIs for web views were designed such that you can do a lot of, frankly, quite dangerous things with these web views. You can inject content into them. You can inject JavaScript to the page. That's primarily used to give you a way to actually communicate across that boundary between the native application and the content that's in the web view. So we work, for instance, we use that to pass some tokens across the boundary when we're showing web content needs to be authenticated. So we had the tokens in the native app. We need to pass them into the web view. And also you can do things like control navigation. So for every sort of navigation event that occurs on the page, you have a hook where you can decide what to do with that navigation event. That is what allows you to, say, replace parts of what that web app was doing with native content by intercepting that redirect and showing like a native view controller. Or you can do things like if it's certain types of redirects, like the redirect for the terms and conditions or a redirect out to some third-party content, you can then dispatch that out to the system browser so it's not occurring within this sort of insecure context within your own app from the third party's perspective. So because of these very kind of like deep integration points you have into the web view, they don't share state with any other web views across other applications or with the system browser. So this is not a mechanism, say, to be able to enable single sign-on between the browser and the app. You have to do that through other mechanisms. But web views can be very, very useful for transitioning an app to native or from native out to web, depending on what it is you're trying to do. So the one solution that Google came up for with this is the idea of an in-app browser tab. And Android, they call them custom tabs. So this is a way for you to display content from the system browser inside your application. So there's none of this like very visible context switch that you would have seen on, say, iOS. It would be like your application's in the front, and whenever you open the web, it would do that. So like every one of these interactions on something like OAuth 2 would trigger these very visible kind of changes in the screen, and a lot of people just didn't like the UX of that. This gives you a middle ground where you can show that web content within your application, but there are some UI elements of what is displayed that you cannot change. So your address bar has to be there, so the user knows that this is web content. In the sort of like drop-down menu at the top right, there's a way to say, open this in the system browser as a way to prove to yourself that this is actually the system browser if you're paranoid about this. And also the cross to just kind of like close out these flows. Originally, custom tabs were designed for, say, linking out to Amazon to show like an item that someone might want to buy, but making sure that they're authenticated with Amazon so they can do like a one-click buy experience. Also to avoid things like having the user authenticate with Amazon inside this web view context where you can potentially be key logging everything that they do. So it's meant to give the user some additional trust that they can do these types of privileged actions without an application stealing their password or stealing their tokens in a way that allows them to compromise the user. You do have a little bit of control, like you can change the color of the top bar and some other little bits and pieces like that, but generally there's this like fixed element to the UI. The one exception to that is if you can prove to the system that your app and the site that you're opening are related, and this is done through, on Apple or on iOS, it's an app site configuration that exists on the domain that says that this site is explicitly associated with this app based on the app ID and the team ID, and then the OS can verify that this is the right app that says it's associated with that. Then you can skip some things. On Android, it's a similar mechanism, just a different structure to that configuration file. It's a shame that we haven't come up with a standard that both companies can agree on that yet. But if you have that, then you can actually completely remove that decoration. So you can make it look like a web view. You still can't inject content or JavaScript into that frame, but you can at least get rid of the top bar, which can give you an even more sort of seamless experience for the user, particularly if you're using this for single sign-on. So if it's single first-party, single sign-on to a domain that the app and the site mutually trust each other, then that decoration can go away. OK, so that's all the sort of layers, isolation, how you can like pierce the veil of those isolations. So one other thing I wanted to talk about is some of the things that make mobile authentication different, and also the ways in which the operating system can help you with some common mobile authentication use cases. But first, as an application developer, you have to make this decision. Do you even trust the device such that you would allow the user to authenticate on that device? This is particularly important for bring your own device use cases where, as a system administrator, you have no idea what the state of that device is. Is it hygienic? Is it rooted? Has it been updated recently? These are the sort of things that would really give you pause as to whether you would allow the user to enter their credentials into this application in a way that they might get stolen if the device is rooted or something like that. So on iOS, this is less of an issue because like jailbreaking is generally much harder and done less frequently. On Android, however, because of the variety of devices and the variety of manufacturers, this becomes a much more real concern. So because of that, Google provides the Safety Net Attestation Api. I love this section, by the way. We'll just be kind of links for further reading if you're interested in this stuff. But the Safety Net will give you that sort of basic signal as to whether this device appears suspicious or not. So it will do things like it will look for apps like Super SU that allow for privilege escalation through the rooted account on the device. It will check if the device has been updated recently or is like essentially on the most up-to-date version that it can be. And it will give you some attestation of that you can send to your backend as part of some request. And then on the backend, you can say, OK, signed assertion from Google. The signature is valid, and this information says that this device is generally speaking trustworthy, so I'll allow authentication to proceed. It's a pretty useful thing to be aware of. The other part is a lot of applications will assume that the device itself provides some security perimeter for user interactions. So for a lot of apps like Amazon and stuff like that, you won't be expected to re-authenticate with Amazon every time you go into the application because they're like, well, we authenticated them once and there's a pin lock or there's biometrics, right? Well, you don't have to assume that. You can actually check. So through Android's KeyGuard Manager API, there's a way to check if there's a device lock or some sort of biometric set on the device. On iOS, through the local authentication API, you can do a similar thing. And both of these APIs are also allow you to do things like reauth through whatever mechanism the device prefers. So you can say on opening something like a banking app, I want to trigger a fingerprint re-verification of this user before I allow them to transfer money to another account. You can do that through these APIs. So very useful technique to be aware of, especially with privileged actions within your application. One thing to make sure you do is like don't just check this once on like the first installation of the application. Check it frequently, especially if this is part of your threat model for how this application could be compromised. So every time your application starts up, do this as like a quick little check, just to be like, okay, pin lock is still in place, or something that I need is still in place for my security model. Another really important technique for mobile authentication is for all of the sort of input elements that you have as part of your authentication flow, or even just generally in your application, annotating these with what the intended data is really helpful to the user and to the system in many ways. So annotating input boxes, this requires an email address, will allow the keyboard to do things like automatically suggest email addresses from the user's accounts on the device to autofill into the application. Similarly, if you annotate a field correctly as a password, which you're probably doing anyway, so that you get the obfuscated text as the user enters, that can act as a trigger for things like device-provided password managers to seed the password into the application without the user typing anything. And I know people have a variety of opinions on password managers and whether they really help with security or not, but I believe that they do, especially because the password manager will do a bunch of checks that the user usually won't. So for instance, when it's looking at a password field, it's like, okay, I need to find the password for google.com, but it'll be checking that it really is google.com. It's not google.com with some like Unicode thing stuffed in there that the user's not paying attention to, or some other type of like phishing attack. And if it's not the domain it's expecting, then it won't fill anything. And that's like a signal to the user, especially if they're used to autofill, that if something is not autofilling, it's like, huh, this is weird. Like, maybe then they'll start paying attention to the fact that they're being phished. There are a ton of input types across the web and native applications. So go dig up the documentation for that and see what type of support you can provide to users. There's one I want to talk about in particular that a lot of people aren't aware of that's coming up soon, so we'll get to that. And one other thing is that if you thought passwords were bad on desktop, they're extra bad on mobile, because if your policy requires people to have passwords with uppercase letters, numbers, symbols, those become especially difficult to type into on a mobile keyboard. You're usually switching the context of the keyboard, paging through multiple pages of symbols to find the symbol that you used. A lot of us will probably have experienced this pain. So on mobile, if you have passwords, really we should be having passwords that are easier for users to enter. That can either be done by saying you have longer passwords that are only lowercase, or if you're able to complement passwords with a second factor, like an SMS OTP or a security key or something like that, you can potentially really simplify the passwords down to the point where they're really just pins. So I need your 4-digit PIN and a tap of your security key, and off you go. Like that sort of thing is really helpful for avoiding user frustration. And as Pam was talking about in an earlier talk, if the user is frustrated, they're generally paying much less attention to whether or not they're being phished. So that's a good way to help with that as well. This is our final point as to whether you even need a password. Just gets into the general philosophy of, now that we have other higher security or side channel methods of authentication through SMS OTPs and the like, maybe you don't even need a password. It depends on what the most privileged action a user could do in your application is. Or maybe you don't ask the passwords up front and you only ask for them when they're about to do something that's really critical in the context of that application. Okay, so SMS is probably the sort of defining difference for mobile devices from desktop authentication. So you have these reasonably secure side channels. Like, there are a ton of issues with SMS and with the networks that transmit SMS that can be compromised. But generally, you're securing the user against the sort of like industrial scale phishing attacks that users commonly experience now. So if you at least have a way of checking that they still have access to a phone number that you've checked previously, that's through a side channel that your app has no method of interacting with, especially now that all those types of permissions have been locked down across both of the primary platforms that we use. So you can use those SMS and even email verification as a mechanism to authenticate the user. And this is one of the things that always stuck with me from my time at Google, is that for most users, password reset is actually the authentication mechanism of choice. They never remember the passwords. They just throw some junk in. They get authenticated through that scheme. And then when they come back in 6 months because they want to buy something else from the site that they haven't touched in 6 months, they're like, I just go through password reset, and that's how I get back in again. So given that so many people are doing this already, and you're not augmenting email re-verification with some other challenge that they really have to remember or something that they have to possess, maybe you just get rid of the password entirely and just use email re-verification as your primary authentication mechanism. So that will very much depend on what the security bar is for the types of things the user's doing in your application. But I would say for the vast majority of consumer applications, this is more than enough. Then finally, so we have the biometric support on most devices, whether that's fingerprint or Face ID, iris scans, that sort of thing. The device is providing some mechanism, usually as a perimeter for the device for unlocking, that you can re-leverage in your application. So if you're worried about users putting phones down on the table that are unlocked and then walking away and someone steals it, for high-touch actions, you can ask the device to do that re-authentication through the APIs that I mentioned earlier. So really what I would say is that if you have a high security bar for your application, doing the multi-factor authentication on first install of the application, and then after that doing frequent biometric re-challenges or using what the device is configured to do, is a good way to maintain confidence that the original user is still present. The point at the bottom here is that support for biometrics varies a lot across different versions of Android. Like we have so many devices in the wild now that haven't been updated in years, so a lot of the good APIs for biometrics on Android come from the much more recent versions of Android, so you have to be prepared for that and have to have some reasonable fallback in the case where you can't rely on biometric auth. So that may be implementing a PIN within your own application that is checked against your own backend. Like that might be a necessary fallback depending on the profile of your users. Android and iOS do both provide ways to help with SMS, OTP style authentication because it's so common. Android has this SMS Retrieval Api where as part of the flow you can say, I am going to expect an SMS with a certain format that will contain a code that I use for authentication. So you sort of throw that at the system, that's the thing that's going to happen. You drive the user through the normal flow, and then when that SMS arrives, it will extract the code and it will give it directly to your app. There are a ton of restrictions around that, and I can't remember all the details of how you register what numbers it's going to come from or what the format of the message is, but that at least does exist so that the user doesn't even necessarily have to copy this code out of the SMS. So like a lot of you probably also experienced that it will appear, but then depending on the length of it, you don't see all of it, and you have to tap through to your SMS and copy out the right bit, and it's just like a really kind of frustrating experience that drives all our users away from what is actually a pretty useful additional bar for security on the device. So these types of APIs make things much simpler for the user. On iOS, they do this through the keyboard, and I was talking about the input type declarations. You can annotate an input field as one-time code, and what that will mean is if a SMS arrives within 3 minutes, I think it is, of when that SMS arrives, if you have a field that's annotated with one-time code, that code will be extracted and offered as an autocomplete suggestion for the user. So it's not quite as seamless as what Android provides, but it's still pretty good. It means that they don't have to go manually copy that code and put it into the application themselves. So finally, we have security keys now. Still not very common, unfortunately, but they are sort of like the ultimate for high security applications. Within Android, we now have built-in support at the operating system level through Google Play Services, and within Chrome through WebAuthn to interact with these types of security devices. Also through WebAuthn, you can do things like generate keys that are tied to the domain of your application, so you can do a lot of the things you could do natively can also now be done on web. Unfortunately, iOS is the gap here still, so Safari does not yet have a WebAuthn implementation, so we can't rely on that universally across the devices that we expect our users to have. And on iOS, there's no operating system provided support for FIDO2 or anything, but there are SDKs that you can integrate that if you get things like permission to use Bluetooth on the device, you can interact with Bluetooth security keys. So it is still possible, it's just more difficult than it is on Android right now. So given all that, which is a lot in the last few minutes, I'm now going to talk about how you would piece some of this together into providing a single sign-on solution on mobile. But coming back to that user perspective, because they see this phone as an extension of themselves, they just get really confused as to why is it when I swap between applications, it's like I'm having to re-authenticate all over the place. If single sign-on doesn't exist, it just becomes a really painful experience, and they don't get it. They're like, this is me. I already told it who I was. Why does nothing else work? So that's where our job as technologists is to make all these layers of isolation and identity context sort of disappear from the context of the user, while still upholding the security that we rely upon. So this is challenging, but there are some libraries and stuff that can help with this. So the main sort of traditional approach to doing this in mobile is the notion of a hero app. So you have the app that's most commonly installed first. So this would be like the Facebook application gets installed first before users install Messenger or Instagram, that type of thing. With Google, the hero app is already pre-installed on the device if it's a Google approved device, so they have Google Play Services. So with that one application, either through the keychain sharing that I talked about earlier, you can propagate account information between apps. Or on Android devices, you can use things like content providers where applications can make these types of like background cross-app requests for information, and you can verify the identity of the other app. But the main thing here is that you know which app to look for first. If you don't have a hero app, you end up with a much more chaotic situation that's sort of like, okay, whichever one was installed first, we don't know which one that's going to be. So either they'll have to be doing some sort of like leader election in the background and deciding which one's going to carry the credential, or they all copy the credential and we hope that they stay in sync. Like, this gets really complicated fast if you don't have that sort of designated hero application to act as the primary identity context. So that's the big challenge with hero apps, though a lot of companies do use this approach successfully. It's particularly useful for large enterprises with a ton of in-house applications. But then the other thing is that, well, every device has a browser. The browser can act as a hero app too. We just need to have a mechanism to interact effectively with the browser, authenticate users or reuse authentication context within the browser, and then pass that information back to the application. And that was the really tricky thing historically. It was getting information back from the browser into the app. So we had a couple of different ways of doing that. We could do it through custom URIs. So an application could register its own scheme for a URI. So it'd be like com.google.gmail : and then any URL with that would be routed to that application as a sort of service hook. However, there was no real sort of proof that the application that you think you're talking to is actually the one behind that scheme. So any app could claim any scheme. There was no way to know for sure that you were talking to the right application to get the right identity context, or maybe you're even like triggering a phishing attack on the user unknowingly by some app having stolen that particular scheme. So then in more recent years, we got universal links, or app links as they're called, universal links on iOS, app links on Android. That gives you a way to securely register against the HTTPS domain. So you can say that this app is equivalent to accounts.google.com. So anything that could be sent to accounts.google.com can be securely routed to this installed native application. So that solved the problem of not knowing if you're talking to the right app or not. But the mechanisms by which that work get kind of tricky. So any URLs that are sent to that HTTPS domain have to come from an explicit user action. So if you're doing like some automatic redirect, the OS will refuse to route it in case this is some attempt to actually phish the user or do something weird with the state of the application without the user being explicitly involved in that interaction. So those types of interconnects still get pretty difficult to implement correctly. So this is where AppAuth comes in. So we started this project about 4 years ago now, maybe 3 years ago. But it was to take all the knowledge that we had as platform developers for iOS and Android and distill it down into an API that just gives you something that looks like a fairly standard expression of OAuth 2. You have your authorization request, authorization responses. You say perform authorization request, and you give it the object that describes the request that you want to do. And it will decide, the library will decide what the best mechanism is to actually perform that authorization request. So in some older versions of iOS, it will do that by actually switching to the system browser. In newer versions, it will use Safari View Controller. Last year, they changed Safari View Controller to AS authentication session. So we do all those types of like device level version switching for you on iOS. And on Android, we will try and leverage custom tabs or send it to a specific browser that you ask for. So as an enterprise, you may actually have some customized version of Chromium, say, that's for your enterprise, and you might want all requests to go to that because that's what the identity context is. So we give you all those ways to specify up front what you want, and the library will take care of the details, including some of the routing back as well. So the aim is really to simplify and hide a lot of these really gnarly details of doing this on each of the platforms. So I highly recommend that if you have to implement some form of OpenID connecting your applications, that you take a look at AppAuth. And whether you use it or not, or just kind of cribbed from those ideas, it's a very useful reference for the types of problems that we had to solve. And that's me. So I have a minute left, and I'm also happy to stay for any questions anyone has. It's been a bit of a whirlwind tour, but thank you for your attention.